So first I will I am going to discuss the syllabus. So today I am just going to start a very interesting topic that is all about potential analysis. This is all about potential analysis. This topic is actually backbone of classical mechanics. This topic is a very fundamental one. So if you understand this thing particularly, then what will happen? You can apply this particular concept into different system, and then you can analyze the system. And if you will aware of this particular fact that some places this classical mechanics is very predominantly known as analytical mechanics. Okay, so analysis is the very important part to understand the system. So it's a very interesting one. So today we will start potential analysis. This is one of my favorite topic, and in this potential analysis we will learn just understanding of potential, and we will just try to learn the phase space or phase curve. And second thing, we are just going to learn that condition of small oscillation. Condition of small oscillation. And then we will also try to go for relevance of equation of motion. We will try to understand what is equation of motion and up to which limit we can solve the problem. This is very important before you want to go in a very deep to the particular stream or particular topics. Okay, and then we will go for equation of motion. Equation of motion. So this is our first part, and this is for every examination. And one question will surely into the IIT-JAM. And there is also JEST examination and TIFR, as well as you can obviously net and gate is always there. Okay, so net and gate is always there. Okay, so this is all this thing. In every examination, this topic is there. And once we will learn the equation of motion, and then we will try to go for equation of motion with a new formulation, that is Lagrangian formulation. So what we will do, we will just go from Lagrangian formulation. Lagrangian formulation. And this is mainly, this is not in the IIT-JAM examination. This is mainly in JEST exam, TIFR exam, net and gate exam. Okay. So this is little bit of higher level of thing, but yes, if you want to go for this examination, this every year 1 or 2 problem is always there. Okay. And then we will go for a Hamiltonian formulation. So these are the formulation part. So again, in all this examination, this is not also in JAM examination. So this is just TIFR, net and gate examination. But if JAM people will giving that JEST examination, it is very beneficial for you. Okay. And after Hamiltonian formulation, we will just go for a canonical transformation. We will go for canonical transformation, and this is in all these examinations. This is again not in JAM, IIT-JAM examination. This is in JEST, TIFR, net and gate examination, and canonical transformation as well as Poisson bracket. Okay, so this is your Poisson bracket. Okay, so these are the formulation part, and then we will go for application part. So once we will learn this, and here we will have also generating function and the time evolution of any physical quantity, everything we will try to learn in this particular segment. Okay, the Hamiltonian and this thing will be so deeply connected, so you can easily learn all this thing. And after these particular thing, we have to just go for analysis part, and we have to analyze some basic system. So first system we will try to analyze is central force problem. Obviously, central force and Kepler's problem. So this is central force and Kepler's problem. Kepler's problem. And this is in every examination, whatever, any examination from IIT-G to IIT-JAM to your BSc examination, MSc examination, NET exam, GATE exam, everywhere you have this particular central force problem. Okay, IIT-JAM and JEST, TIFR, obviously NET and GATE also. NET and GATE also. And then we will go for a second part is the second thing is a small oscillation. So again, this small oscillation chapter is in every examination. In every examination. Then we will go for moment of inertia. This is again in every examination. Okay. And then we will go for little bit of rotational dynamics. Rotational dynamics. So this is also in each and every examination. So these are main topic you have to go for in the, and obviously scattering is also there, but I will take a scattering in quantum mechanics. First in the quantum mechanics, I will do classical scattering, and then we will just use same concept to the quantum mechanical scattering. So it is much better that we should learn both things together. So scattering is very separate topic and we will do it separately. Okay, so these are the topics, and you can see that every year most of the questions we are able to do on the basis of this particular program or particular curriculum. And it is very nice to say that every year the level of question in each examination is actually going harder and harder and harder, mainly classical mechanics part. Okay, so you have to be very much conscious about classical mechanics concept, and you have to be learn the definition and concept in a very minute level. The best thing of the classical mechanics is that you need not to remember any formula. So this is one of the best thing. And these are basically concept based thing, but what is toughest thing into the classical mechanics, that if it is not a formula based topic, then what you have to do, you have to understand concept and use your mathematics in a very nice way. So this is a little bit more mathematical topic than formula based topic, and the calculation should be very smooth and it should be very deep rooted calculation. What are the background mathematics behind the classical mechanics is the differential equation. So, and basic differential equation, and I am not saying that you should go for very toughest differential equation, just very basic differential equation, second order differential equation, first order differential equation, mainly the problem which will give you sinusoidal solution, damping solution, this kind of thing you have to remember to analyze your classical mechanics system. Okay, so if you have any doubt here, you can raise, you can suggest me something. Otherwise, I will just go for my first chapter, that is classical mechanics. And in each and every examination, if there is a 100 marks question, then at least 20. So out of 100, it will take 20% of the syllabus or the marks. So it's a very important. And second thing is that classical mechanics will also help you to understand quantum mechanics and statistical mechanics. So the once you learn the methodology here, it will help you to do statistical and quantum mechanics. Then your level of marks will increase. So effectively, it will 20% is the minimum thing you can expect from classical mechanics. And yes, one next topic is STR. I keep always STR, special theory of relativity, separate. Okay, this is entirely different thing I am taking, not into this particular segment. We will take in different segment. Okay, so I think everybody is satisfied with my argument, or if you want to add, you can add something. Okay, so now which book is the best book? Everybody wants to learn some book. So I will straightforward suggest a best book is Goldstein. This is basically, you can say, Gita or Bible of classical mechanics. And the next book I will suggest you, that is the book by Landau. This is a very nice book. I will just give you this is a book, so you can just see, or if you're able to see this particular book, this is a classical mechanics books, course of theoretical physics by Landau, and this is a very thin book, so it's a very nice to learn this thing. Okay, but yes, the concept is very concise here. So the second book I will follow is Landau, and if you want, you can buy this book. This is very nice. And Goldstein is awesome book. So everybody should learn Goldstein through his whole life. So my main jinx will be from here. And some another book I can also go for the problems, that Morris and Morin. We will go for the problems. That is also very nice book. And the best part of Morris and Morin is that you have lot of solution is also given here. But I will suggest you should go for unsolved problem more and more. But obviously we have to finish these courses into this mainly 1 month. So it is very difficult to follow all the books. So I will suggest you should just go for my class notes, my tutorial, as well as your booklet, whatever we are going to provide from the from institute side. Okay, so this thing, and for the JAM students, the best book is basically Klapner, and is the one of the fundamental book. Everybody, JAM student or NET student, everybody should have this one copy of Klapner with themselves also. But I will cover all this thing in my notes. So your notes will be a main thing that you have to focus. So if you will focus your notes, out of 20%, you can, out of 8 or 9 questions, if any examination from classical mechanics is there, you can easily solve 6 to 7 examination, and that is more than enough to complete. Okay, so if you want anything to add me for the first class, hence it is our first class, so obviously we should little bit of ये तो हमें करना ही पड़ेगा, है ना? Okay, you can talk to me, don't worry, you can talk to me, but when I speak, then please mute yourself, and when you want to speak, you can unmute and talk to me. So any suggestion?
No, sir.
Okay, okay, great. So don't worry, बहुत ही मजा आएगा, and I think I should continue into mainly English, isn't it? Or some people wants that I should mix the thing, Hindi or English.
Please explain in both the languages.
Okay, okay. So you can ask me in the both language. Okay, और जहां आपको समझ में नहीं आती है, you can easily talk to me in your language. Okay, I can little bit understand Bangla and Odia also, so there is not any problem. Okay, so but मैं सिर्फ समझ सकता हूँ, I cannot speak. Okay, so let's go for our first chapter, and this is all about potential analysis. Now, before going to potential analysis, And let me ask one particular question. We have different type of system, isn't it? We have n type of system we can have. Okay. So our suppose this particle is moving freely. Another particle is going to attach with a spring, and it can just do to and fro motion. You know that the spring mass system is just a manifestation of simple harmonic motion, and this is one of the fundamental system which will execute simple harmonic motion. You have simple pendulum. It's a very fundamental system. You have a particle which is going to go, and there is some charge on a particle, and you are putting it in a electric field. And this type of system, you can have two charged particle. This is your Q1 and this is your Q2, and you have this interaction between two charged particle can be also there. And let's say I am just want to analyze the motion of this particle whose mass is m. So my question is that every time we have this particular mass m, this particular mass m, and mass m. If what will be the difference in one system to the another system and another system to the next one? What are difference here? कैसे आपको पता चल रहा है कि that same mass will execute entirely different type of motion? Their physics will be entirely different. Obviously, everywhere you have the same mass, isn't it?
Yes.
Everywhere you have same mass, isn't it?
Yes, sir.
Yes, sir.
You have same mass, but what is the different part that you are just what is that which will make them different? क्या है इन्हें different बताता है?
Sir, equation of
Sir,
motion से पता चल जाएगा.
The force
Obviously-
acting on it, sir.
Exactly. Equation of motion is nothing but the next part of understanding the force, isn't it? Before
Yes,
you
sir.
will know the force, then you will write equation of motion. You will not write equation of motion force, then you will understand force. Are you
Yes.
getting my point?
Yes, sir.
So force is the fundamental thing. And who will generate force? How you will generate force? With the help of potential. Are you getting my point?
Yes, sir.
Unless until there is not any potential or there is not any field. If you have field, you have potential. If you are potential, if you have field. Field is just something just you can just translate into a force, isn't it? So gravitational field, you have gravitational force. Electric field, you have your electromagnetic force and all this kind of thing, isn't it? So obviously, the most important thing is if we know the force of a system, somehow, अब जैसे भी निकालना है, जैसे भी trick use करना है, that is different issue. But if we know the force of a system, then easily we can write a equation of motion, and this equation of motion is nothing d square x upon dt square. Isn't it? This is our equation of motion, md square x upon dt square. And if you have this equation of motion and if you are able to solve this one, then obviously you can analyze your system. This is most fundamental thing we have to do. Now, how you are getting this force mathematically? Mathematically, this force can be derived with potential. In the one dimension, actually we are just working for the one dimensional system currently. You can just use this concept for 2 dimension and 3 dimension also. But in a one dimensional system, if this is my force, I can define my force with the help of potential, and that force is nothing but minus del V upon del X. This is all about the definition of force. So, and it is very good that we should work into the scalar, because if you are working into the vector, then it will little bit more problematic. So why, if we can do the analysis of potential in a very nice way, we can easily do the analysis of force. And once we can do the analysis of force, you can easily write equation of motion and you can just go for next level of calculation. Are you people appreciating this, or you want to add something on this?
सर ये विषय तो फोर्स को कंजर्वेटिव होना जरूरी है ना.
Obviously, we are just talking about conservative force right now. You are absolutely correct. Okay, but for the non-conservative system के लिए भी तो हम force लिख सकते हैं. And that will also we will use in the Lagrangian formulation when we will use the generalized coordinate and Lagrangian formulation. वहां पर उसके बारे में बात करेंगे, है ना? But right now I am just assuming that my potential is only and only function of position. That will not a function of velocity and obviously time. Okay.
Yes.
Okay, sir.
Okay. Great. So it is very important to analyze the potential and analyze the force simultaneously. So obviously, if I have my potential, and obviously this is for the conservative force, then my potential is Vx. I can find the force, and that force is nothing but minus del V upon del X. And if my force F is equal to 0, that implies del V upon del X must be equal to what? 0. Del V upon del X की value क्या हो जाएगी? That will be 0. So this value is 0, means force is 0. That means your system is at equilibrium. So this is obviously at some point, not every point, at let's say x is equal to x naught. Then my x naught is identified as equilibrium point. Equilibrium point, isn't it? Then this is identified. So this is known as what? Equilibrium point. Now let us try to go mathematically. So if somehow we are just going to plot this potential Vs versus X, then maybe this kind of potential can be there. I am just taking one general potential. So now your del V upon del X will be 0 at this point also, and this is 0 at this point also, isn't it?
Yes, sir.
Okay, this is 0 at this point also,
Yes.
this is 0 at this point also. So one point can be minima and another point can be maxima. It may be possible. Okay, it may be your x naught. It may be also your x naught. You can have more than one equilibrium point. Then obviously, if we are talking about this particular point, or we are talking about this particular point, the basic nature of a particle is entirely different. The basic nature of a motion is entirely different. Look at what is going to happen when we are just going to displace the particle from here to here and again from here to here. Then what will happen? The particle will go here and again it will try to come into at this point, isn't it?
Yes,
The
sir.
particle will just go some up to some particular point and again it will come to this point. You can imagine you have big bathtub type of thing, and which is this parabolic kind of thing. If you will put the ball, then ball will go up and again it will come down. It will go up and again it will come down, isn't it? Either you will give the left and right, it will just do this type of motion, isn't it? So if you have this type of motion, then obviously this point will try to restore your particle at the point x naught, isn't it?
Yes, sir. Yes, sir.
है ना? पार्टिकल
Yes,
क्या
sir.
कर रहा है? उसे रिस्टोर करने की कोशिश कर रहा है at the point x is equal to x naught. But look at the property at this particular point. If you, and obviously the particle just want to restore at this point. So we are saying that the particle have feelings of restoring force, isn't it? That means that if we are taking the displacement, which will be negative sign of the displacement from the equilibrium point, isn't it? Because the displacement is, the force is acting against the displacement. Now, look at what will happen to this particular point. At this particular point, it will just go and it will just go and go. It will never try to come automatically at this particular point unless until we will not push with some energy to this particle and it will go back. It is very difficult that you will take particle from here to here. But it is very easy that if we will just displace it and it will just go like this. And again, you will displace it and it will just go like this. So you can see this particular point is just behaving like an attractive point. It has feeling of attraction to the particle. That point has enough attractive power that your particle can want to come at this particular point, isn't it? It just want to come at this particular point. And what will happen to this particular point? Obviously, this will always try to repel your particle. It will just try to repel your particle. You can take an example of your simple pendulum. If you have simple pendulum, suppose this is my simple pendulum. If I am just going to displace slightly, then what will happen? It again, it's always try to come at the minimum point. Always try to come, isn't it? But what will happen when we will just go in a inverted form? Then what will happen if it will, you will give the little bit of thrust, then it will go 2 pi, 4 pi, 6 pi, isn't it? This kind
Yes,
of
sir.
thing is there unless until you don't have any resistance to stop this particular motion. So you can see this x is equal to x naught can have two different type of property. So why we are giving the two different name to the property, to this 2 point. So first point is basically stable equilibrium point. So this is basically known as stable equilibrium point. Now, from your sense, from your feeling, which should be stable? First one or second one? Minima or maxima?
First one, sir, minimum.
First one. You have sense, na? You have feeling. यार वहाँ particle stable रहना. Every natural thing want to stabilize itself, isn't it? So yes. So a stable equilibrium point. So what is condition of a stable equilibrium point? The condition of a stable equilibrium point is del V upon del X is equal to 0 at X is equal to X naught, and this point must be minima of your potential, that is X is equal to X naught, must be greater than 0, isn't it? So this is condition of what? Stable equilibrium point. And if we want to go for unstable equilibrium point, so what is your unstable equilibrium point? Then what will happen? Unstable equilibrium point. Then you will go for del V upon del X must be equal to 0, and this is unstable. So del V upon del X must be 0 at X is equal to X naught, and we have del square V upon del X square, X is equal to X naught must be less than 0. So this is your unstable equilibrium point. So stable equilibrium point is actually minima of a curve, minima, and unstable equilibrium point is actually maxima of your potential. So this is your stable and unstable equilibrium point. If you want to add something, और अगर आप कहीं पर आप परेशान हो, डाउट है, then you can ask me, then I will go for one particular problem. Everyone is comfortable?
Yes, sir.
Okay. अगर आप कुछ नहीं बोलोगे तो मैं समझूंगा कि आपको समझ में आ रहा है. ओके?
Okay, sir.
ओके. चलो, एंड प्लीज एंजॉय टॉपिक, है ना? आराम से एंजॉय करो. इट्स अ वेरी इंटरेस्टिंग टॉपिक. ठीक है, बहुत मजा आने वाला है ना? एंड आई थिंक मैं भी कुछ सीख पाऊं इस पूरे क्लास से, है ना? कि हर एक बैच में मैं कुछ ना कुछ सीखता ही हूँ. ओके, एंड थैंक्स टू ऑल माय स्टूडेंट्स जो कि मुझे कुछ ना कुछ नई ट्रिक्स हर बार बताते हैं. एवरी टाइम दे विल गिव अस न्यू ट्रिक्स. जैसे इस बार मोमेंट ऑफ इनर्शिया कैलकुलेशन में मुझे मेरे एक स्टूडेंट ने इन ऑफलाइन बैच में नए ढंग से चीजों को कुछ करने के लिए सिखाया. सो देयर आर ऑलवेज वी हैव दिस थिंग, है ना. सो सिर्फ आपको ही नहीं सीखना है, आपको भी मुझे थोड़ा बहुत सिखाना है. ओके, क्लियर है ये?
Yes, sir.
ओके, ग्रेट.
Yes, sir.
चलो, सो लेट्स गो फॉर वन प्रॉब्लम. एक प्रॉब्लम करें क्या, और उसे एनालाइज करते हैं पूरे प्रॉब्लम को, और देखते हैं क्या क्या चीज हम एनालाइज कर सकते हैं. इजंट इट?
Yes, sir.
ओके, ग्रेट.
Yes, sir.
Sir.
बहुत ही मजेदार टॉपिक है ये, एंड दिस इज वन ऑफ द माय फेवरेट टॉपिक ऑलवेज. जब ये टॉपिक खत्म होगा तो फिर आपको पता चलेगा कि आपने फर्स्ट चैप्टर ऑफ नॉन लीनियर डायनेमिक्स एक्चुअली सीख लिया है. ओके, सो आई एम taking this thing from the nonlinear dynamics. Okay, so and we will also discuss what is nonlinear dynamics, don't worry. So let us go for a potential that Vx is equal to x square by 2 minus x cube by 3. So this is our potential. So, and this is very nice potential. Okay, so first we want to find stable equilibrium point and unstable equilibrium point. Second thing what we have to do, we have to just plot Vx versus x. And third what we have to do, we have to plot force versus x. So actually we have to learn to plot a curve also. Okay, so let's try to go for this. Everyone is comfortable? Okay, so let's try to go for this. So for the stable equilibrium point, we have to just go for del V upon del X is equal to 0, and which implies x minus x square must be equal to 0. You can take minus sign, but in right hand side you have 0, then it also works. So what will happen? So here x is equal to 0 and x is equal to 1. Okay, and now we have to check which point is a stable equilibrium point and which point is unstable equilibrium point. Then first order derivative is not enough. You have to go for your second order derivative. Then what you will do, del square V upon del x square at x is equal to x naught is equal to 1 minus 2x. And for x is equal to x naught, at x is equal to 0, what will happen? Del square V upon del x square at x is equal to 0 की वैल्यू क्या होगी? 1, isn't it? And that is greater than 0. So x is equal to 0 is stable or unstable? Huh?
Stable, sir.
That is
Stable.
stable equilibrium point. Very good. And it is also identified as what? Minima of a curve. ये क्या आइडेंटिफाई करता है? मिनिमा ऑफ अ कर्व. यस. सेकंड थिंग, सेकंड जस्ट गो
Sir.
फॉर डेल. यस, बोलिए.
Please explain this last one, what you have explained. Last part.
अभी जो बताया ये ना.
Yes, sir.
ओके, देखो ये मैंने फर्स्ट ऑर्डर डेरिवेटिव लिया तो इससे मुझे ये दोनों पॉइंट मिल गए, है ना. दीज टू पॉइंट इज बेसिकली इक्विलिब्रियम पॉइंट. ओके, जहां फोर्स की वैल्यू क्या हो रही है? 0 हो रही है. ओके, एंड नाउ if you want to check which one is stable and which one is unstable, you have to go for second order derivative, isn't it?
Yes, sir.
So second order derivative लिखा तो 1 minus 2x. Are you able to do this thing?
Yes, sir.
Yes. Now put x is equal to 0 here. What you will get? 1. 1 is greater than 0.
Yes, sir.
So it is minima of maxima.
Minimum of the curve.
Minima. Then it is stable or unstable?
It is stable.
Very good. So what this is, I have just done this here. Okay.
Okay.
अब जरा बताओ x is equal to 1 पर क्या होगा?
So -1.
Minus 1. That is less than 0. So what is
Yes,
this?
sir.
Maxima or minima?
This
Maxima.
is maximum.
Maxima. So x is equal to 1 को unstable कहें या stable कहें?
Unstable.
Unstable equilibrium point. Very good. Great. सीख तो गए. ये क्या है? maxima. Now, next target is that we have to plot this potential, and then we will also plot the force. And once you will plot force, then you will realize which type of system can be there. क्या हो रहा है, कैसे हो रहा है, ये फिर हम तब realize कर पाएंगे. Okay, it's a very interesting. Let's go for this. So now you have this particular thing. So now we have to plot our potential. So before plotting the potential, we need some more information about this particular thing. So let us try to go for some more information, because plot करने के लिए और भी कुछ information हमें चाहिए होंगे. Okay. So let's try to go for some more information. What is this information? Let's try to go for. So first thing, where is my Vx is basically x square by 2 minus x cube by 3. Now just please tell me, where is my potential is going to 0? किस पॉइंट पर 0 हो रहा है? बताइए. x की वैल्यू क्या है? 0 और x की वैल्यू क्या है? 1.5. Isn't it?
Yes, sir.
इसको आप इक्वल टू 0 करोगे तो 0 और x इक्वल टू 1.5. ठीक है. Now just tell me what is value of at x is equal to 0 and x is equal to 1. So what is value of 0? Obviously this is 0. ये तो यहीं से मिल गया है from here. And what is v1? कैलकुलेट करो. x की वैल्यू 1 पुट किया कि 1/2 minus 1/3 is what? 1/6. So this is your Vx. Now we can plot it easily. Look at here. So now when you have minima, then you have this type of shape, concave upward. When you have maxima, then you have this kind of shape that is convex downward. Isn't it?
Yes, sir.
Okay.
Yes, sir.
So let's try to go for this. So let me plot this potential here. So when we are just trying to plot this particular potential, then at x is equal to 0, what do we have? Minima or maxima?
Minima.
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 And v is 0 is equal to 0.
0.
So this is your minima. Okay. And what will happen to x is equal to 1?
Maximum.
Maxima. And x is equal to 1, you have maxima. And what is the value of potential at x is equal to 1? 1/6.
1/6.
So 1 you will go to 1/6. So let us assume there is 1/6 or some here. Then it will go downward. Okay. So it will go something like this, and again it will go downward. What will be this point?
1.5.
1.5. Very good. So now you can just go like this. You can have this type of potential. So this will be 0, this will be 1, and this will be 1.5. And this is your potential. You can easily plot. Yes?
Yes, sir.
है ना? So this is your potential. हम लोग इसे एनालाइज करेंगे. कब हार्मोनिक ऑसिलेटर होगा, कब अनबाउंडेड मोशन होगा, which kind of thing will be there, that will be come into later class. But right now you can just see this is your wonderful potential. Let's try to plot force, and this is very interesting. And then we can analyze point by point by seeing the potential and seeing the force, what is going to happen to your particle. Okay, let's try to go for this. यहाँ तक clear है ना everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Good.
Sir,
हाँ बताइए.
sir, in this representation of Vx versus x, the upper part of the curve where आपने minima दिखाया था जिस जगह पे, वो x स्क्वायर को वाला फंक्शन को डिनोट कर रहा है, और x क्यूब वाला फंक्शन को सर कौन सा पार्ट से?
नहीं, आप इसको ऐसे करके नहीं देख सकते हो, है ना, बिकॉज दीज आर मिक्सिंग ऑफ बोथ थिंग. ओके, ये दोनों का मिक्सिंग है. ओके, सो यू हैव टू सी द कंप्लीट पिक्चर. वैसे करके आप रेयरली देख सकते हो. ओके, बट आप बना सकते हो, देयर इज नॉट एनी प्रॉब्लम. आप कर सकते हो। एक्स स्क्वायर होगा तो समथिंग लाइक दिस, और एक्स क्यूब होता है तो उसका प्लॉट कैसा होगा? व्हाट विल बी एक्स क्यूब? Something like this,
दो
na?
कोऑर्डिनेट के अंदर से
Something
हाँ,
like this.
yes,
Okay, something like this, isn't it? So
yes.
obviously it will be very tough to, and you have minus sign here. So what will be effect of this minus sign? इस तरह से आप बहुत जल्दी नहीं बता सकते हो, ठीक है? So it will be really tough to solve each and every problem like this. Okay, so but best way is that you can just go for maxima, go for minima, find the turning point, isn't it? You can see these 2 points are transition point. Why? This is minima. What is meaning of minima? Meaning of minima, if you will move towards right or move towards left, the point will be minimum to their neighborhood, isn't it? And what is maxima? If you will move towards right or move towards left, that point will be maximum of their neighborhood.
Local
I am-
minimum.
And
local
yes, very good. So we are just trying to figure it out. What will be local minima and what will be local maxima? Okay. So, and I think this is the best way to draw the potential, because every time that doesn't work, but sometime it will work very nicely, but not every time. Okay. Now let us try to go for a force curve, और force को हम लोग देखते हैं. What will happen to your force? So let us try to go for calculating the force. Okay. So when we are trying to calculate force, so force Fx is nothing but minus del V upon del X. This is very interesting. Fx is nothing but what? Minus del V upon del X. And what is your potential? Vx is equal to x square by 2 minus x cube by 3. प्लीज किसी का अनम्यूट है? म्यूट कर लो अपना, है ना? जब आपको जरूरत हो तो आप अपना अनम्यूट कर लो, है ठीक है? बट अदरवाइज कीप योरसेल्फ म्यूटेड, अदरवाइज मेरे कान में कुछ ना कुछ आवाज आती रहती है, ठीक है? Okay, and that is very irritating actually. So minus x plus x square. So this is your force. This is your force. Okay. Again, we have to plot this force. So how we are just going to plot it? Again, we will find where this force is going to 0. Then at which point the force is maximum or minimum? Is that any chance that force have getting some maximum or minimum or not? So let's try to go for this. So where is your force is going to 0? Obviously minus x plus x square must be equal to 0. So x is equal to 0 and x is equal to 1. And yes, these are the basically what? Stable and unstable equilibrium point, isn't it? You remember the thing जो हमने देखा था अभी? So
Yes,
yes,
sir.
at this point your force, so at the stable and unstable point, your force is actually 0. This is very interesting. Now let's go for next point. We just want to calculate where is my force is going to maxima or minima. So del f upon del x is equal to 0. That implies minus 1 plus x plus 2x is equal to 0. So x is equal to 1 by 2. So there is only one transition point for force. So let us try to figure out what is that transition point. The force is maximum or force is minima. So what we have to do? We have to just go for del square f upon del x square, and fortunately that value is 2, and which is greater than 0. Then obviously at x is equal to 2, the force is maxima or minima?
Minimum.
Minima. So let us try to, first I am going to calculate first potential, and then I will also calculate the force. So this is my potential, isn't it? This is my potential, something like this. Okay, let us try to calculate force. And obviously this point is 0, this point is 1.5, this point is 1. Okay, so these are 3 important points, and all points are ordinary point. Either it is monotonically decreasing or monotonically increasing. So Let us try to calculate force. Let us find what will be the value of force at x is equal to half. So what is value of force at x is equal to half? So minus, so F 1 by 2 is, I am just calculating here. F 1 by 2 is given by minus half plus 1 by 4, isn't it? And what is this value? What is this value? Minus 1
minus
by
1 by
4. So obviously this is negative. Now look at this particular plot. So at x is equal to 0 and x is equal to 1, my force is 0, and it is minima at x is equal to half, and the minimum value of force at x is equal to half is minus 1 by 4 unit. So my force will be something like this. Are you getting my point? Your force will be something like this. Now look at what is going to happen. When your particle is moving from left, or some minus infinity, you can calculate all the value of force. At x is equal to, what will happen? The force is continuously decreasing, isn't it? You have initially some positive force, and you are moving towards x is equal to 0. Then force will be 0. And then what will happen? You have some negative force here, and your force is going to continuously decreasing up to the point at x is equal to half. And after half, what will happen? Suddenly your force start increasing, isn't it? Suddenly your force start increasing and again find 0, and then it will become positive. So look at, this is your practically the behavior of force, isn't it? This is your practical behavior of force, because at least you can know what is going to happen to your system. Obviously, if your force will be going to decrease, then obviously acceleration is also going to decrease. At some point, your force is 0, the particle will have 0 acceleration at this particular point, isn't it? So you can just check what is going to happen to your system. Clear है ये?
Sir, please repeat once.
फिर से रिपीट कर दें, देख लो. मैं लेफ्ट से राइट की तरफ जा रहा हूं. ओके, आई एम मूविंग फ्रॉम लेफ्ट टू राइट. देन व्हाट विल हैपन? You have some higher forces in a positive sense, yes? And जैसे जैसे मैं इस राइट की तरफ जा रहा हूं, फोर्स क्या हो रहा है? डिक्रीज करता जा रहा है. Yes, it will become positive. Sorry, it will become 0 at x is equal to 0, and after then again it is going to decrease and reach some minimum value of force. ऐसा नहीं है कि वो कंटिन्यूअसली डिक्रीज करते जा रहा है. सम मिनिमम वैल्यू ऑफ फोर्स पर पहुंच रहा है, और उस समय मिनिमम वैल्यू ऑफ फोर्स क्या है? दैट इज नथिंग बट minus 1 by 4. And after then what will happen? After then what will happen? After then again your force start increasing. Yes, your force start increasing, and you will just go into this direction. Yes, same kind of thing is also if you are moving from left to right or right to left. You can see which kind of property of force is there. So it will depends on your motion कि आप किस पॉइंट को क्रॉस कर रहे हो, किस पॉइंट को क्रॉस करने के बाद क्या मिल रहा है. Isn't it?
Yes, sir.
और ये, and now please, why this plot is so important? Because if we are going to solve the equation of motion, and what is this equation of motion? D square x upon dt square, and this fx is, what is this value of fx? Minus x plus x square is equal to m d square x upon dt square. Let us assume m is equal to 1. So you are just going to solve this equation, and that value is equal to x square minus x. Are you able to solve this differential equation in a very easy manner?
No, sir.
No. Why not? Why not?
Second order.
Yes, this is second order. X का second order है, second power 2 है, and this force is not a linear. You have actually non-linear force. Are you getting my point? Or when you have non-linear force, then it is very difficult to solve the equation of motion. So you cannot analyze anything with this mathematics. At least in your pen and paper. Yes, you can use your computers, you can use your programming acumen. But if you want to analyze your system with the help of this equation of motion, I think somebody have asked me that equation of motion is enough to do the analysis. But where you can do this type of analysis here from this equation of motion? You cannot do. But yes, if you can plot this particular potential, after then if you are going to plot this particular force, at least you can say what is happened to your system, where your particle will be accelerated or where your particle is not going to accelerate. At least you can say all this particular thing. कर सकते हैं ना?
Yes.
And the सबसे बड़ी प्रॉब्लम ये है कि हम क्लासिकल मैकेनिक्स में मैक्सिमम लीनियर टर्म ही सॉल्व कर पाते हैं. Whenever non-linear term come, you need very high level of mathematical acumen और कंप्यूटर प्रोग्रामिंग. बिना कंप्यूटर प्रोग्रामिंग के तो नॉन लीनियर इक्वेशन सॉल्व ही नहीं हो सकता है. यस
Yes, sir.
सो दिस इज वेरी इंपॉर्टेंट थिंग टू अंडरस्टैंड. लिमिटेशन समझना बहुत ही ज्यादा इंपॉर्टेंट है कि भाई हमारी लिमिटेशन क्या है और हम उस लिमिटेशन को कैसे दूसरे ढंग से एनालाइज कर सकते हैं. ओके, एंड दिस इज योर एनालिटिकल मेथड जिसके थ्रू आप चीजों को इजिली सॉल्व कर पा रहे हो. इसके लिए आपको न्यूमेरिकल टेक्निक ही यूज करना पड़ेगा. ओके
Yes, sir.
okay, so I think I have next another class. So I am just giving you one homework, and I suggest, if I am giving you homework, please do with yourself and post in your group. Okay, so इसे आप please post कीजिए, and tomorrow class we will just go to analyze another potential, and we will see what will be condition of a small oscillation and all this kind of thing. Okay,
Yes, sir.
everyone is comfortable? Okay, so let me give you one homework. दो homework ना, या फिर नहीं चाहिए?
Very good.
चाहिए ना? Very
चाहिए।
good, very good, very good. वैसे मैं तो नहीं चाहता था कि मुझे कोई होमवर्क दे ज्यादा, बट यू पीपल आर गुड स्टूडेंट्स, है ना?
Yes, sir.
चलो, so let's try to go for one particular question. So simple है, same है. So Vx is equal to x square by 2 minus x4 by 4. Okay, Vx is equal to x square by 2 minus x4 by 4. First you have to find stable equilibrium point, unstable equilibrium point, and second you have to do plot Vx versus x, and third you have to do plot fx versus x. हो जाएगा ये स्ट्रेट फॉरवर्ड
Yes.
जैसा
Yes,
किया है, सेम प्रोसेस करोगे, है ना? देन ओके, एंड देन ट्राई टू गिव मी द सॉल्यूशन. मैं इसे कल डिस्कस भी करूंगा, डोंट वरी. ठीक है?
Yes, sir.
ओके, सो सिर्फ एक क्वेश्चन दिया हूं होमवर्क, सो कभी भी खेलते कूदते बना लेना. ठीक है? है ना? ओके,
Yes, sir.
चलो, थैंक यू,
Thank you, sir.
Thank you, sir.
थैंक यू, थैंक यू.
Thank you, sir.